Okay, for this problem we have a PDF that is piecewise defined. Between 0 and 1 the function is the function line y equals x, and between 1 and 2 it is another line 2 minus x. And so that is the PDF for this random variable, capital X. First off, find the probability that capital X is less than or equal to 1.5. So the chance that x is less than or equal to 1.5, that's the integral from 0 to 1.5 of f of x dx. And for this problem, because it is piecewise defined, I have to do it in two parts. Integral from 0 to 1, x dx, plus integral from 1 to 1.5 of 2 minus x dx. So I want to find the area from 0 to 1.5. From 0 to 1, I use this part, and from 1 to 1.5, I use this other part. So that's equal to x squared over 2 from 1 to 0, plus 2x minus x squared over 2 from 1.5 to 1. So the first part is 1/2 minus 0. The second part is 3 minus, plugging in, we get 2.25 over 2, minus, and we plug in 1, we get 2 minus 1/2. And coming out the other side, we get that the area is equal to 0.875. So that is the area to the left of 1.5. The second part of the problem is looking for the 90th percentile of the distribution. So I've already established that 87.5% of the area lies to the left of here, and now I want to find the 90th percentile. So the 90th percentile, I'll mark that here. I want to find the number so that this area here is equal to 0.9. Now, because I've done this extra work, I know full well that this number over here, whatever it is, I'll mark it as t. This number t has to be between 1 and 2 because the area for this problem between 0 and 1 is only 1/2, 0.5. So the 50th percentile is here, so the 90th percentile must be over here someplace. So for part 2, I want the integral from 0 to 1 of x dx plus the integral from 1 to t of 2 minus x dx. I want this to be equal to 0.9. And the ultimate goal is to solve for the value of t that makes this work. Okay, so we integrate. Once again, over here we have x squared over 2 from 1 to 0. Over here, once again, we have 2x minus x squared over 2, but this time evaluated from t to 1, and I want this to be equal to 0.9. So we have 1/2 minus 0 plus 2t minus t squared over 2 minus 2 minus 1/2 is equal to 0.9. And now this becomes an algebra problem to solve for the value of t. Okay, so let's start simplifying this as best we can. We get 1/2 plus 2t minus t squared over 2 minus 3/2 is equal to 0.9. Let's bring everything over to the right-hand side. So this negative t squared over 2 becomes positive t squared over 2. The plus 2t becomes minus 2t on the other side. 1/2 minus 3/2 is minus 1. Comes the other side as plus 1. So I get plus 1.9 over here. And for the sake of simplicity, let's double it. So we have t squared minus 4t plus 3.8. And now we'll just use the quadratic formula. T is equal to 4 plus or minus the square root of 16 minus 4 times a times c is 15.2 divided by 2, or 4 plus or minus the square root of 0.8 divided by 2. Now I know full well that it's going to be the minus here. Why do I know it's the minus? Because 4 divided by 2 is 2, and the answer must be something that's less than 2. So the plus would be an extraneous root. So 4 minus that, so finally I get 1.5528. Now, not surprisingly, I get an answer that's bigger than 1.5. The area to the left of 1.5 was 87.5%. In other words, The 87.5th percentile was 1.5. So it makes sense that the 90th percentile is going to be something that's bigger than 1.5.